what is an arithmetic series? Now, if I were to look at this given sequence, we can see that this is an arithmetic sequence with a first term of 2 and a common difference of 5. If I were to add the terms of the sequence, the sum of the terms of this sequence form an arithmetic series. So by definition, a series is in fact the sum of the terms of a sequence. Now, in order to evaluate this sum, I need to start by observing the given pattern. If I were to start by adding the first and the last term, I notice that the first and the last term have a sum of 49. Similarly, the second term and the term before the last have also a sum equals to 49. And so on, adding the two terms on the same position of either ends of the sequence, I notice that I always end up with the same sum equals to 49. So if I were to denote that sum I'm looking for by S10 as it is the sum of 10 terms of the arithmetic series given, then S10 would be equals to 49 added to itself 5 times. So S10 would be equals to 49 times 5. So in order to start building an expression for an arithmetic series, I need to go back to the pattern I started with. So the first 49 I obtained was in fact due to the sum of the first and the last term, which in this case is the 10th term of the series U10. So every 49 I obtained is in fact equals to U1 plus U10. So in the expression I have for S10, I replace 49 by U1 plus U10. And since I started by adding 10 terms, then the 5 I'm multiplying with in S10 is in fact equals to 10, the total number of terms, divided by 2. So since the total number of terms I'm adding is 10, then I can generalize that to n terms and replace 10 by n. Consequently, I obtain an expression for the sum of the first n terms of an arithmetic sequence. So the sum of the first n terms of an arithmetic sequence is given by Sn, which is equals to n over 2 into u1 plus un. So it's the sum of the first and the last term of the sequence multiplied by the number of terms I'm adding divided by 2. However, un being equals to u1 plus n minus 1 times d according to the general term of an arithmetic sequence, and making that substitution, replacing un by its expression, I end up with the sum of the first n terms being equals to n over 2 into 2u1 plus n minus 1 times d. So I end up with two possible expressions to determine the sum of the first n terms of an arithmetic sequence. And the choice of the expression really depends on the context. For example, if I were to go through this first example here, I am given an arithmetic sequence with a first term of 3 and a common difference of 6. And suppose I aim to find the sum of the first 7 terms. So I go back to the two possible expressions I have for the sum of the first n terms of an arithmetic sequence. So since I'm given the first term and the common difference of the sequence, in that case I choose to use the expression for Sn that uses the first term and the common difference. So using that expression, I start by replacing u1 and d by their corresponding values. However, since I aim to find the sum of the first 7 terms of the sequence, in that case n would be equals to 7. So I replace n by 7. Evaluating that, I end up with S7 equals to 147. Going through this next example, I am given an arithmetic series that starts with 4 and ends with 28. So in order to find that sum, I also need to refer back to the two possible expressions I have for the sum of the first n terms. Now over here, since I'm given the first term and the last term, in that case, I need to use the expression for Sn that uses the first and the last term. So using that expression, I start by replacing u1 and un by their corresponding values, 4 and 28. And in order to find that sum, I still need to find n that represents the number of terms I am adding in that series. And since n represents the position of the last term in the series, in order to find n, I need to first start by finding the common difference. So the common difference of the sequence in this case is equals to 2, as I'm adding 2 to move from one term to the next one in the series. So using the general term of an arithmetic sequence, by setting un equals to u1 plus n minus 1d, I first replace u1, d, and un, the last term, by their corresponding values. So the only unknown I have left here is n, so I solve for n. So first, I would have 2 into n minus 1 equals to 24. Consequently, n minus 1 is 12, which leads to n equals to 13. So in this given arithmetic series, I am adding 13 terms. So going back to the sum of the first n terms, I replace n by 13. And evaluating that, I end up with S13 equals to 208. So this arithmetic series has a value of 208.